Hello and thank you for joining our Pure Storage webinar this morning. So we have John Wilkins here from Bytes and Max Brown from Pure Storage who will be going through the webinar with you.
Morning. Right, we've got Max Brown from Pure Storage. It's a fairly new partnership for Bytes, but Pure have a unique message, which is flash cheaper than disk. Because of the way they handle the data and their software allowing huge data reduction, that's how they achieve this. This means that the main objections many customers have to buying flash are eliminated. They've also announced an exciting new range of products in the last few days, and Max has got a great way of delivering the subject matter, so I'll hand you over to him.
Okay, thank you for that introduction. Hopefully you can all see my screen now. So yeah, I'll just, as John said, I'll kind of cover off some of the high-level points around Pure, a couple of technical slides because I'm aware that we've got a mixed audience, and obviously feed in any questions into the text box, and then we'll address those at the end. So if we look at Pure Storage, who we are and where we've come from. So the company was founded in 2009. Some venture capitalists got one of our guys out of retirement, a guy called John Colgrove. So the reason I mention this person is this was the guy who was the technical founder at Veritas Software. He pretty much wrote the Veritas Volume Manager and file system. So he's got decades worth of experience in the storage industry. And then John Hayes, who's our chief architect, came from a non-storage background, from the Web 2.0 scale-out infrastructure, and he'd recently sold his company to Yahoo. By putting these two guys together, the venture capitalists could see that the time is right to do an all-flash array, but to do something clever to make it more affordable for your Tier 1 enterprises. So the first product launch was in early 2011. We now have about 1,000 units shipped worldwide. We've got about 600 customers. We've got over 500 employees. We've had about 470 million investment, and this money isn't to prop us up. So we already had a lot of money in the bank, and then we had our most recent round of funding of 225 million, and this is basically to massively expand our reach both geographically and technically. In terms of valuation, I'm not obviously allowed to comment on any rumours or speculation, but if you did look in the press, you'll see some analysts reckoning we're around the 3 billion valuation mark. We're growing about 700% year on year. I mean, from personal experience, I know that in Europe, in March last year, we had 3 employees, and we're pretty close to having 50 now. So everything's expanding massively. So I see flash as is this decade's IT disruption. So if we think what was the last disruptive technology to hit IT, it was pretty much VMware, virtualization. That changed a lot of things. That changed IT radically for a lot of people. And I think flash is going to do the same thing. So if we just look at spinning disk, so the 15K hard drive, which is as fast as they spin today, that was released in early 2001. That is the only piece of technology I can think of, maybe apart from a mainframe, that people are using that is more than a few years old. So people are still buying 15K drives. I talk to customers that are looking at buying a big disk array from a Tier 1, from a big name vendor, and they're going to have it for 3 or 5 years, and they're going to cram it full of technology that is already 12 years old. To my mind, that doesn't make sense. If we look at Moore's Law, CPUs, servers, everything's getting faster every year. The disks are a massive bottleneck. Now, if we look at flash, it's obviously much faster. It's much smaller. It consumes a lot less power, but the barrier to entry has been cost. If the same cost per gigabyte of a 15K drive was the same as a flash drive, everybody would buy flash. Nobody would buy spinning disk. But that's not the way it is today. So Pure Storage, we are flash for the enterprise. So performance, we are not the fastest all-flash array on the market, and nor do we intend to be. We're not going for the 1 million IOPS, 2 million IOPS rate, because to be honest, the amount of customers that need that is extremely small. What we're going for is the Tier 1 enterprise space. So people that have got their very large brand name disk arrays and it's time to do a refresh, these are the kind of people that should be looking at an all-flash array from Pure. Because, as it says, less cost than disk. I mean, it depends on how you price it. But on the whole, if I could sell you a disk array that was entirely full of flash for the same cost per gigabyte as an identical array from another vendor but full of 15K spindles, you'd buy an all-flash array. And the way that we do this is via some intelligent data reduction technologies so that you get a lot more out of the flash than just the raw capacity. But it's not, it's no good being a performance system and being very cost effective if you're going to suffer downtime, if when a drive fails your performance absolutely goes through the floor, if every time you need to do a firmware upgrade you need to do it at a quiet time on 3 a.m. Sunday morning. We've designed our system to have mission critical reliability. From our dial home statistics we can see that we have pretty much close to 6 nines availability. And it also needs to be scalable, so we scale from the tens to the hundreds of terabytes. And it's compatible with what you're using today. There's nothing particularly clever when we're presenting the storage out to the servers. We run iSCSI or Fibre Channel or a mix of both. We present out raw block devices to the servers. So it looks the same to your servers as any disk array, apart from the fact this goes exceedingly fast and pretty much has zero downtime. And it is unexpectedly simple. Now the reason I say this is that I'm sure every vendor says their technology is easy to manage. Well, this truly is one of the easiest ones to manage. And I think as a follow-up after this, if any of you would like to see a demo, then we can arrange a separate briefing session. But it is the easiest storage I've ever had to manage. So if you look at the flash price barrier, if you look at the flash appliances kind of a pinkish line at the top, that's the cost per gigabyte without doing any type of data reduction. In other words, it's still really too expensive to buy, apart from people that need that tier 0 kind of sub-millisecond financial trading response. But with the benefits of a data reduction technology with dedupe and compression, this is where you are now getting the cost per gigabyte down to the same cost as spinning disk. So at the top of this screen we've got something called the dedupe ticker. If you go onto our website you can see this live in real time, and all of our Pure storage arrays dial home every 30 seconds and dump a load of metrics into our support database, and from that we can see what the average dedupe ratio, compression ratio, and therefore overall data reduction ratio is across all of the Pure storage arrays deployed in the field. And currently it always stands around 6:1. So if we look at the costs of storage, so on the left hand side you've got your traditional spinning disk. Now the problem with traditional spinning disk is whatever you buy raw you lose. So the simple example, 5 drives in a RAID 5 means you've lost a drive, therefore you've lost 20% of what you've just bought. So your raw cost actually, when you look at usable, increases. From the OPEX perspective, you've obviously got your maintenance, which depending on which vendor it is, it's anything from 15 to 25% a year, so that's kind of a given. But if we look at the power and the space that spinning disks consume, it's quite hefty. And then if we look at the management side of things, most spinning disk arrays take a fair bit of management, a lot of thought, a lot of configuration, a lot of dials that you need to tune and tweak. Now if we compare that to pure flash arrays, obviously cost per gigabyte of SSDs is not cheap. No one ever said it was. But with our data reduction technologies, we can get that down to a much more manageable, usable cost. Maintenance is a given, you have to buy support. But if we look at the power and the space and the management, so we consume about 9 or 10 times less power than traditional spinning disk arrays. The amount of space we take up is a quarter or less than what you would traditionally have. And the management of this is so easy that in some instances we've sold this and we let Oracle database admins do all of the storage work because it is that easy to use. So why would you want to go all flash? I think that the simple answer here is if you look at the bottom of the pure all flash array, we don't have a red zone. There is no slow zone that we could go to. On a traditional disk array, you have lots of spinning disks of various types and sizes, and you have a read and write cache. And anything that comes out of the read and write cache is extremely low latency and fast. But if you can't read from cache, you have to go to disk. If you look at something that has some of these hybrid arrays that have SSDs as a caching layer, I mean, that's all well and good. So you might get 80%, 90% of your IOs will be satisfied from that caching layer. But every time you get a cache miss, you have to go to really slow storage. So you can only be as fast sometimes as your slowest storage. It's kind of the weakest link. With an all-flash array, there is nothing slow that we can go to. The slowest component in our system is SSDs. So simplicity, the things that have been a pain in the neck for most storage admins or server admins or anyone that's had anything to do with spinning disks. So for a start, RAID. RAID has been the big bugbear for everyone. Do I do RAID 10 for the performance and lose loads of space, or do I go RAID 5 or 6 for more resiliency, but actually the performance is terrible? Then you have things like host array and block alignment, and then troubleshoot performance bottlenecks. You know, the worst performance bottleneck that I think everyone has encountered at some point in time is what's called the noisy neighbor effect. So if I'm running workload A and I'm wide striping across a load of spinning disks, and then someone does a huge backup job or a giant database query that affects job A, then everything starts to suffer. So that noisy neighbor can be a real killer. And then the amount of tuning and tweaking that you've got to do. I mean, I've seen some of the manuals that come with some of the tier 1 vendors, the 5-day training courses, and some of the training courses are just literally to set up replication, for example. Well, with Pure, we don't have any tuning, there's no tweaking, there is no training course, there is no professional services, because it is literally a half-day exercise to rack it, stack it, and train a customer. You know, storage should be that simple. So no RAID rebuilds, well, no day-long, 20-minute RAID rebuilds, worst case. There are no tiers of storage. It's extremely simple. So in terms of where we fit in the market, basically, high-end or mid-range OLTP type workloads, random IO workloads. So server virtualization, if you're running VMware, Hyper-V, Zen Server, KVM, we fit perfectly in those environments. If you're doing databases, so if you're running Oracle databases or SQL, MongoDB, Hadoop, you name it, then again, perfect fit for Pure. And virtual desktops, we suddenly become, the cost we can provide per desktop, it suddenly becomes a no-brainer to do virtual desktops. In most environments, the disk has been the killer. It's been the thing that has prevented VDI from taking off. We're absolutely a VDI enabler, and we're getting data reduction from 10 to 15 times more. So as a quick example, I guess kind of the bottom of this screen gives you the headline figures of a customer that had 150 terabytes of traditional spinning disk, which they got down to 35 on Pure, which meant they went from about a rack and a half of storage to about a quarter of a rack. They went from the amount of power that they had to 8 times less power, but also database went 8 times faster, database backup went 9 times faster, and the OPEX cost of being in a colo much, much lower. One of our other major customers in the US, a large global insurance vendor, so this is some stats out of their out of their VMware environment. So they were getting around 20 to 26 milliseconds latency on all of their jobs. As soon as they transferred over to Pure, they dropped to a sub-millisecond latency. And you can see these various tiny, tiny spikes where, as they were running production on Pure, they failed a controller, they did a firmware upgrade, they pulled SAS cables, and it makes no difference to the performance. It was always still sub-millisecond latency. So for this customer, they got a 7.6 to 1 data reduction. They're using it for their high-end kind of customer-facing activities, running Oracle SQL, VMware, virtual desktops, and they did their own internal TCO. So these companies have 14 petabytes of storage, not of Pure, but in total. And they did the maths to say, if we didn't deploy Pure and we deployed everything the same that we have done for the last 10 or 15 years, how much would you spend over 5 years? And it was 25 million. They now looked at the figures and said, right, if we now deploy everything on Pure that is applicable to Pure, such as your database environment and your virtualized environment, then it's going to cost them 10 million. So for these guys, $50 million saving over 5 years in a 14 petabyte environment, it was, again, a no-brainer. Their challenge to themselves is to stop buying spinning disks, except for where they need 4 terabyte SATA drives for a petabyte archive of, images or something, which wouldn't be a good fit for Pure. So better transaction time. So again, they had issues where I think they were doing a nightly batch job in the US, which was supposed to finish in time before the UK came online, but it didn't. So the UK was coming online while the batch job in the US was still running, so they were actually running on stale data for the best part of half a day. And it also given them the enablement to virtualize the final 10% of their environment. So where they were not able to virtualize some database servers because of the I/O performance metrics, they can now do that with Pure. So we have a Love Your Storage guarantee, which very simply says if you buy one of our units and within 30 days you don't like it for any reason, we'll take it back. And we haven't had to take any one of these back yet. Something else we've introduced from a commercial aspect. So pretty much every storage array that you buy, you will buy it with a certain amount of support, let's say 3 years or 5 years. And generally what happens at the end of 3 years is when you get your quote for years 4 and 5 support, it's extremely high. It's almost exorbitantly high. And that's mainly because the vendor you're talking to would actually like you to purchase new hardware. So you've got two choices. You either purchase some new hardware, which means you've now got your old disk array and your new disk array in your data center, consuming twice as much power, and then you've got two things to manage, and then you have to go through a very painful and sometimes protracted data migration exercise. Alternatively, you keep your existing disk array, and then you end up paying a fortune to support some technology which is now 3 years old. With Pure, we've introduced something new where we are removing this, what I'd call the tech refresh headache. So if you buy support from Pure for 3 years, or you buy 5 up front, kind of a 3+2, at the end of year 3, we will give you free controllers. We will upgrade your controllers to the latest, greatest. So you now have the most performant controllers that are available on the market for Pure Storage, and we do this at no cost, as long as you buy support for years 4 and 5. And the support uplift is not great. It's not exorbitant like many of the other vendors. So the way that we replace these controllers, it can be done online with zero downtime and zero performance loss. So no one will actually, no one will actually see the impact of these being replaced, except for the fact they're now bigger and faster. Alternatively, we have something called fresh every upgrade. So the other issue with maintenance terms is if you buy a disk array with 3 years support, and then at the start of year 3, you buy an additional disk shelf, and that disk shelf has 3 years support, you've suddenly got depreciation overhang because of your maintenance terms. So most of your disk array has got 1 year's maintenance left, but this new shelf has got 3 years left on it. We are then happy to reset all of your maintenance terms at the then current pricing. So that way we can reduce the depreciation overhang and any of the confusing maintenance terms. So it's a very simple way to true up your maintenance and support contracts. In terms of some UK customers, obviously I can't name names in a public forum, but we have global car rental business, 2,200 seat VDI, another 2,000. So every branch that you go to in the country to rent a car, as the people are tapping away on their keyboards, filling out all the details, there'll be a virtual desktop that's connected to Pure. We also have a large betting company. So you can see the example. They created a copy of their production environment every day. It used to take them 6 hours, so they had to let it run overnight. So this was 400 virtual machines, 180 applications. They can now do this in 40 minutes. As a result of seeing this performance, they're now moving all of their core front-end custom-facing revenue-generating databases onto Pure. We've got a cinema chain that's moved off legacy disk. They tested us against the hybrid array. But again, because hybrids are hybrids, there is SATA drives in there and some spinning disks, they could not get the consistent performance. We've got foreign exchange trading companies, we've got high-speed video games companies, we've got large asset management companies. For all of these companies, the same thing applies. We've got massive performance. We've got a lot more uptime. We've got easier manageability. We've got reduced OPEX costs. If we look at the loans company at the bottom, and this was a simple one, we made them go faster, which means the more loan applications they can process, the more money they make. Very simple. We've got a large NHS trust in the north of England, and this is for their VDI initiative, and we recently did a firmware upgrade, and we do all the firmware upgrades remotely. The firmware upgrade was done at 10 a.m. on a Friday morning with all of the users hitting the system, and no one saw anything happen whatsoever. So it's this whole concept of not having to schedule any outages or downtime or a quiet time in order to do work on the Pure Storage flash array itself. So I'll get kind of slightly into technology. So one key thing to take away from this is that the Pure Storage flash array is designed for one thing only, and that is to work with flash devices, to work with SSDs. It has no idea what a spinning disk is, and it never will. So the fact that pretty much every spinning disk array on the market now supports SSDs doesn't mean that's a good thing. So if the firmware or microcode, call it what you will, inside your disk array has been designed to understand how to overwrite magnetic sectors on a spinning disk, when you put in a flash SSD, it's not going to treat it the same way. You can't overwrite on an SSD. You always have to write to new space. So you may hear people talk about things such as garbage collection, write amplification. These are all bad things that can affect the performance of your normal disk array, and it can also drastically affect the longevity of the SSDs themselves. Now, because we've been tuned to work with flash and flash only, we completely understand the best way in which to write the SSDs that we use. So by doing that, that means we always get consistent sub-millisecond performance. It always means that the drives don't wear out as quickly, so we give about a 7-year warranty on our drives, so we're not concerned with wearing them out. But the key thing is it's 100% designed to work with flash. If you think you can put SSDs in a standard disk array, you're kind of hoping for the best. There are actually some vendors out there, some large name vendors, that will sell you SSDs for your standard disk array but will not sell you support because they know it will wear out quickly because they're not handling it correctly. In the same way that if a storage vendor says we can show you the wear level on your SSDs, the only reason they're showing you that is because they know it's going to wear out quicker than it should because they're not treating it correctly. So the whole of our Pure operating environment consists of, and I'm kind of reading this from the bottom up, we have the MLC flash drives. At our core, we have this flash care and the consistent performance, so this is kind of making sure we get the best performance and the lowest latency. Our adaptive metadata fabric, and then above that we have dedupe, compression, pattern removal. We have the protection, all the recovery of replication and snapshots, and then some very good management tools above, and I'll touch on each one of those fairly briefly. So in terms of benchmarks, so if you get a data sheet from any vendor, generally, and to be honest, we used to be guilty of this, but we've now changed our data sheets, is you would quote the best case example. So in other words, you'd probably quote your performance figures based on 4K or 8K IOs, read, 100% reads, no writes in a kind of, perfect environment. If you actually look at most environments, no one does 4K or 8K. 38K is our average IO size, so on the whole, call it 32K, that's pretty much what most customers are doing. We actually have designed our disk arrays to work with variable block sizes. So whether you're doing a 4K IO or a 128K IO, we treat them all as the same. We treat it as one IO. Now, many other vendors will have a fixed block size. So their disk arrays, or in fact their flash arrays as well, will be designed along 8K or 4K IO boundaries, which means if you send them anything bigger than 4K or 8K, it has to cut that up into chunks and do it as multiple jobs. I've even seen one vendor that actually has a document saying, re-architect your database to have an 8K block size. Well, that's, that should not happen. That's, a case of the tail wagging the dog. The database administrator should design the best database he wants for his application, and the storage should fit around that, which is exactly what we're doing. We are optimized for the real world. So non-destructive everything. The top 3 blocks in this slide, if I talk about non-destructive capacity expansion, doing software or firmware updates and replacing hardware due to failure, I would like to think that every vendor on the planet can do this non-destructively. I know there are some actually that can't, but you should be able to do this with 0 downtime. Now, what the thing is that most vendors don't tell you is, yes, you can do this with 0 downtime, but what they don't tell you is there will be a massive performance impact. With some architectures that some vendors have, when you're doing something like a firmware update in a dual controller architecture, so one controller goes offline to do a reboot, when that reboot happens, your performance drops by 50% because you've just lost 1/2 of your processing engines. The way that Pure is designed, that when you're doing a firmware update, you do not see any change in performance whatsoever. Everything stays kind of sub-millisecond, hundreds of thousands of IOPS. You won't notice anything happen. That is why we can do firmware updates to customers' arrays in the middle of the day with thousands of virtual desktops, hundreds of VMware virtual machines, Oracle databases. It doesn't matter. It makes no difference. It's the same if we add capacity, and it's the same if we actually have to swap out any hardware. There is no impact on performance whatsoever. We can also do non-destructive performance expansion, and what I mean by this is actually swapping your existing controllers for newer, bigger, faster controllers. Now, for most environments, it's not possible to do this, or if it is, you know that there may be some downtime associated or a huge performance hit while you're doing this. With Pure, this does not happen. So if I remove a controller, I remove one of the old controllers, insert a new controller, and then I cable them together. So I'm now running an active-active HA cluster. One controller is the new version, one controller is the old version, and they will coexist quite happily, and that's how we've designed it. And then once you're happy that it's working, you would remove your other old controller, so now you've got a pair of new ones. The way that we've achieved this, to kind of very briefly summarize the architecture, is that we do not have the write cache residing within the storage array controllers. Our write cache is actually done by putting NVRAM devices within the disk shelf. So this means that both the controllers can see multiple NVRAM devices. So if I only have one controller running because the other one's doing a reboot for a firmware update, or it may be that the controller has actually failed for whatever reason, your remaining single controller still has access to a non-volatile mirrored write cache. And that's what gives us our zero performance loss. So resiliency perspective, as I mentioned, it's active-active, it's highly available. All of the volumes are available on all of the ports. We don't contain, we do not keep any important configuration data on the controllers. It's all held across the shelves themselves, and all of the components are hot swap like any traditional disk array. But again, this is all flash. From a RAID protection perspective, so we have, we've coined a concept, things we protect against. So when you say RAID, everybody thinks of protecting drives, protecting a RAID set when a spinning disk fails, which is kind of what we do. So we can protect against dual drive loss. You could lose any two drives within any shelf on a pure storage array. But the way that we write to our disk arrays and the way that we get massive amounts of longevity, so we've shipped roughly 30,000 SSDs globally, and the amount that we've actually had fail, that have actually gone wrong and we've needed to ship replacements, is less than 10. This is purely because of the way that we write to them, the way that we treat them, in order to make them last a lot longer and perform optimally. So number one, we protect against dual drive loss. If you did lose two drives, which we've not seen happen yet, but if you did, or if you were doing it as a test or proof of concept, pull out two drives. We will only rebuild the data that was on those drives, and even if those drives were full, it takes no more than 20 minutes to do a rebuild. So the other things we protect against are bit errors. If you look at an SSD, it's made up of these flash cells. These flash cells are electrically charged, much like a rechargeable battery, and they store electrons to dictate whether it's a 1 or a 0. The problem is, if these cells lose their charge, you'll get the bits start to flip from 0 to 1 and 1 to 0. So if you start getting bit errors, you're going to get corrupt data. We always go around ensuring that all of the flash cells are optimally charged. So if we see a flash cell that we think hasn't been charged for a while, we can free up the space in that, what they call an erase block on the SSD, and then we can recharge those cells. So we're never going to be at the mercy or at risk of any bit errors. And we also protect against variable latency. So by doing this, what I mean is we never read and write to the same SSD at the same time. Now in a spinning disk environment, it's just impossible to do that. You will be reading and writing from the same drives at the same time, hence you get the noisy neighbor effect. Now with SSDs, we can do this differently. So if I'm writing to drive number 1, and I also get a request to read data from drive number 1, what would happen is that read request would be denied, and it would actually rebuild that read from the data and parity on all of the other drives. Kind of in the same way as, how do I read data if I pull a drive out? Your RAID algorithm kicks in. Similar thing, if I can't read from drive 1, I can read from drives 2 to 20, and I can reconstruct that read from the data and the parity. So this non-blocking I/O ensures that you don't get the noisy neighbor effect, and that reads and writes don't kind of trample on each other's feet. From a data integrity perspective, we have multiple layers of data level, page level checksums, lots of independent parity. We generally, the way we've designed it is to not have any type of data corruption within the disk array itself. So there's a lot of technical detail on this slide. I won't go into it into great detail, but some of the highlights are we disperse, we write all of the data evenly across all of the SSDs. Our virtualization chunk size, in other words, when we're writing down to disk, when we're doing our deduplication and compression, we're doing it at a 512 byte virtualization chunk size. This is how we can avoid host array and block alignment. This is how we get such great levels of deduplication and compression. From a geometry perspective, we align ourselves with what's called the erase block. If you have a quick look on Wikipedia and just search for erase blocks on SSDs, you'll kind of understand what this is. But it's the way in which an SSD will do its own internal works, in its internal workings in terms of things like garbage collection and thereby things like write amplification. If we can minimize the amount of work that the SSD is doing, we'll get better write performance, we'll get lower latency, and we'll get better longevity of the drives. So for the non-blocking reads and writes that I just mentioned, the quality of service monitoring is actually from a higher level in terms of monitoring what's the fastest path to the drives in order to read or write the data. And we're always continuously optimizing in the background. So our deduplication and compression is 100% inline. It never turns itself off. And then once the data is on disk, we will continually optimize in the background. So when the data first comes into the system and hits the NVRAM devices, which is in effect our write cache, we do the dedupe and we do a very kind of rudimentary level of compression. Once the data is then destaged onto the standard SSDs, we then have algorithms that will apply much heavier weight compression. So if we have some spare CPU cycles, we do more compression. And then when we do the garbage collection to ensure that the flash cells are fully charged, to maintain the wear leveling and make sure all the drives are working optimally, then at that point when we do the garbage collection and read the data into memory, we can then apply some very heavy compression. So you get a lot of value out of our inline data reduction, and you will get additional value that once the data is on the SSDs, we will apply deeper levels of compression, and we'll also do a dedupe sweep just in case there was anything we missed. So ultimately it's about this flash personality layer. It's about the fact that Pure understand the fingerprint of each SSD. So if we were to use, if you had a shelf of Toshiba SSDs, and then you expanded and put in your expansion shelf, but we happen to be shipping Samsung SSDs, for example, if there was a difference between the Toshiba and the Samsung SSDs, we would be aware of that. Our code would be designed to work with that, because it could be that the Samsung has a 1 megabyte erase block size, the Toshibas might have a 2 megabyte erase block size. We would match those boundaries exactly so we understand the best way to write to those individual SSDs. So to give you an example of how we save space, and this is kind of an example from a VDI environment. So you've got your data set, 512 kilobytes of data. Well, firstly, everything we do is thin provisioned. So we never write zeros to disk. The next thing we do is we scan for any patterns. So are there any 512 byte blocks that are filled with the same repeating byte? So once they've gone, we would update our metadata table to say there's a lot of repetition. We then look at dedupes. So we'll do we'll kind of do a hash sum based on SHA-1, and then we'll compare that with our metadata database, and we can also do a byte for byte comparison to check that we haven't got any hash collisions and that it is real duplicate data. So then that obviously gets removed. So then lastly, we are left with our unique blocks of data. At that point, we would compress them down, and once that's compressed, we then create what we call RAID 3D segments. So as you can see, it's unique data plus some metadata and then some parity blocks. These RAID 3D segments are small. They're less than 100 megabytes in size, so there'd be lots of these RAID 3D segments. These then get written to the back-end SSDs and are wide striped across all of the SSDs. So as a very simple before and after, it's quite plain to see how simple it can be to get these data reduction technologies. And again, this is all 100% inline, it's never turned off, and then when it's on SSD, we can actually apply heavier algorithms to get even better data reduction. So flash recover, this is our kind of terminology for snapshots and replication. So with Pure Storage snapshots, there is no impact on performance. So traditionally, on spinning disk array, your snapshots would cause performance. I've actually seen on some systems where the user guide has said don't take more than 8 because copy on write will absolutely kill performance. With Pure Storage flash arrays, there's no impact on performance. And also, it has a very, very minimal overhead. We never store the same block of data twice. So in effect, if I have a 40 gig virtual machine and I hit the button to say clone this virtual machine, it literally does it in 2 seconds because all we're doing is creating metadata pointers. Then with that 40 gig virtual machine, if I wrote 6 gig worth of new data either to the original virtual machine or into the snapshot that I've maybe mounted up, because of the dedupe and compression, if it's VMware, for example, that 6 gigabytes of data will actually be 1 gigabyte of data that we're writing. So we're writing 6 times less data to the SSDs, which again extends their life, and it also means, this is where you're getting down to the same cost per gigabyte as a disk array with 15K SAS or fiber channel drives. This is something that customers love, especially the database administrators, because you can take as many snapshots as you like. You can take way more than you would have done previously. You don't have to have your snapshots mounted on separate volumes or on separate parts of the disk array or on a separate disk array. You can have your snapshots on your production. We even have customers that have gone from having spinning disk arrays where they had one disk array for production and one disk array for test and dev because they were well aware of the noisy neighbor effect. With Pure Storage, some of the customers that have seen the benefit of it and the fact we don't suffer from the noisy neighbor now run production and test and dev on the same Pure Storage flash array with zero impact on performance. So then leading on from snapshots, we have our replication. So the replication that we do, it's asynchronous point in time. So it's snapshot-based replication. We will take a snapshot, look at the changes, and replicate them every minute. Again, it's automated as far as you want to automate it in terms of you can specify policies to say, I want to take a snapshot every hour and keep 24, or maybe I want to take a snapshot or replica every minute and keep 60. It's entirely up to you. You decide. We can have up to 5,000 active replication sessions at any one time, so you can literally have one replica kicking off every 0.6 seconds. In terms of how we do the policies behind this, so our protection policies, you can either say, I want to replicate a volume or a LUN, kind of same terminology really, or you could say, I want to replicate a group of volumes, because maybe I've got 5 volumes that relate to a SQL database or one of your applications. Or you can do it at a host level to say that any volumes attached to host A will be replicated every minute, which means that when you add a new volume to host A, it will instantly be replicated. You don't have to worry about, I need to configure every single volume. You can attach it, do it by a host protection. And we can do a one-to-many, many-to-one, so I could have one volume, or I could have one array that is talking to, in this example, 3 other arrays, or maybe I've got 3 arrays that are replicating their volumes back to one large central protected Pure Storage flash array. So, one of the questions, and again I like to ask this to the database administrators because, from what I've seen, database administrators have always got bogged down in storage and have their own thoughts and ideas around storage when, to be honest, their job is to design and manage the database. Their job is not to be concerned with storage performance, but they've had to be concerned with it because the storage performance has been a large bottleneck. So, again, block size. So the DBA would often say, what size is your, what is the block size of your storage array? Because I need to design my database to fit that perfectly. Well, it doesn't matter to us. Whether you're doing a 4K block size, 16K, 32K, 128K, it makes no difference to us because we process all IOs as one IO job, which then gets coalesced in our NVRAMs and then written as RAID stripes to the back end. If you're running Oracle, the DBAs would have to make a decision. Do I use ASM, whereby the Oracle database is talking directly to the raw devices, or do I have a normal file system, which in some instances would cause an overhead? Again, with Pure Storage, it doesn't make any difference to us. What about the LUN layout? Do I need to have lots of LUNs to balance my workload or to balance the connections on the array? Or, how do I design it? From Pure perspective, we don't care. I would probably recommend that you just do it from a simple management perspective. So for each database, have a volume for the database files, a volume for the dump, a volume for indexes, and a volume for logs. Just for pure simplicity, just something easy to look at. It makes no difference from a performance perspective whether you've got one big LUN or lots of smaller ones. And there is no RAID decisions, nothing that the customer has to think about at all. So there's no RAID 10 for logs and RAID 5 for databases. The Pure Storage flash array will give you more performance than you need. We have we have a pseudo RAID protection happening in the background, but it's not something that you need to give any thought to. And because we're all flash, there is no caching layer, there is no tiering layer, there is no concept of hot blocks being moved up and down. It's all 100% flash, so everything is at full performance. You can very easily grow and expand the LUNs online, click a button and it's done, and then as long as your file system can expand the file system on the fly, then it's very easy to do. And with the snapshots, you can take as many snapshots as you like because each snapshot you take will be deduped and compressed. One thing I didn't mention, so our replication is dedupe and compression aware. So for example, if I'm in a VMware environment, I had 60 gigabytes worth of data. Through our data reduction technologies in VMware, we get around 6:1. So instead of sending 60 gigabytes of data across the wire, we'll only send about 10 gigabytes, which means we're going to reduce your bandwidth needs. That will increase the frequency that we can do the snapshots, and it gives you, kind of better recovery point objectives as well. So from a support perspective, every storage array on the planet, apart from those ones that are in a dark site or a secure military site, they will dial home every 30 seconds, and they will dump a load of metrics into our centralized cloud assist database, which means that we can do real-time monitoring. So as an SE or a technical account manager or support perspective, we get a snapshot view into exactly what your your storage array looked like 30 seconds ago. So we can actually get it painted into a GUI, so we can see the volumes that you've got, the host you've got connected, how things are configured in terms of, fiber channel worldwide names, iSCSI connections. Obviously, we can't see the data within the volumes, but we can see how your storage has been put together. And also, as a result, if we find any bugs in firmware, for example, we might find that there's a bug in some old firmware. We know exactly which customers are running that version of firmware. We can proactively notify them and say, look, we found a bug in the firmware. We recommend that you do an upgrade. In fact, we will do the upgrade for you. When would you like us to do it? We liaise with the customer. The customer clicks a button in the GUI to allow our support personnel access to the storage array, and then we would do the upgrade with zero downtime and zero performance loss. So the customer wouldn't see anything happen in their environment, and we'd go ahead and do the upgrade. So the ability to do this global analytics also gives us further insight into what customers are doing and helps us develop our product for the future. So in terms of the Pure Storage family, so we've originally, up until about a week ago, we only had the the storage array in the middle, the FA420. We've now introduced the FA405, which is a smaller unit, and the FA450, which is a much larger unit. So as you can see, the FA405, so the usable capacities that we're quoting here are based on a 6:1 data reduction, which is the global average of all of the Pure Storage arrays dialing home. 6:1 is typically what we get in VMware environments or virtual server environments, so Hyper-V, VMware, Zen Server, etc. If you were doing VDI, you would get much better data reduction ratios. In fact, if you're doing VDI, you can pretty much double those numbers. And if you're doing something like databases, then, especially for things like an Oracle database, we get about 3:1 data reduction, so it'd be roughly half. But based on 6:1, you can see we have the FA405, which goes up to 40 terabytes usable, and you're getting 100,000 IOPS. Now, the IOPS figures that we are quoting are based on the 32K block size. We did used to quote 400,000 IOPS based on 4K block size. We no longer do that. We quote our IOPS based on the real-world environments. So 100K IOPS, and this only takes up, the controllers take up 1U each, and the disk chip takes up 2U. So, in 4U and about 600 watts, you've got a very, very powerful disk array. So if you went to a normal disk array vendor and you said, I would like 40 terabytes of usable capacity with, up to 100,000 IOPS, you're going to get something that's going to take up close to, half a rack or maybe even an entire rack's worth of spinning disk. It's going to take up anything close to like between 8 and 10 kilowatts of power, whereas you look at Pure, and this is going to take up about 4U of rack space. It's going to consume less than a kilowatt. So, we've had many customers that have justified the cost of Pure based on their colo OPEX savings alone. So I was recently talking to a customer who had a large tier 1 disk array, and it was a rack full of 15K disks, and he actually said, we're using 9 kilowatts of power on that disk array. If I switch to Pure, I'm going to go from 42 U's worth of space down to about 10 U's worth of space on Pure, and I'm going to be using a kilowatt. And they were getting charged per kilowatt for the power in their colo facility. So for those guys, there was an instant, real, dramatic financial saving. So the FA420, this is the array that we've had for the last couple of years, up to 125 terabytes usable and about 150,000 IOPS at 32K block size. And then we have our larger array that we've just announced, the FA450. So this one goes up to about 1/4 of a petabyte of usable capacity. It does around 200,000 IOPS, again at 32K, and also it supports 16 gig fiber channel. So the other disk arrays, the 405 and the 420, they support 8 gig fiber channel and 10 gig iSCSI, and you can mix and match them. So you may have 4 fiber channel ports and 2 iSCSI ports on each controller. So we're more than happy to mix and match on each controller. So just to summarize before we go into any Q&A sessions, we are 100% flash. So as I mentioned earlier, we do not have any spinning disk. There is no slow component of our system. Our systems, in terms of releasing new models, our systems are completely 100% commodity hardware. So our controllers are standard x86 architecture. But we load some very intelligent operating system and some very intelligent software onto these controllers, which then turns them into a very fast, very powerful storage array controller. The disk shelves are standard Xyrotex that you'll see used by many other vendors. The disks themselves are in hot swap disk caddies like many vendors, so it looks like a normal disk array. The SSDs we use are standard off-the-shelf Toshiba and Samsung. It kind of varies from year to year depending on what availability there is. But the key thing with our performance is not the fact that it's fast, it's the fact that it's consistent and predictable. You can't make a pure array go any faster or go any slower by tweaking knobs and setting different tunable parameters. There is nothing within the GUI that you can do to actually change the performance. So in terms of our high performance data reduction, it is always on. So it's always on, and it's always in line for deduplication, compression, thin provisioning, and encryption. You cannot turn any of those features off. If you could, it would potentially go faster, but we didn't want to expose to customers any complexities around if I turn this on, it goes slower, if I turn this off, it goes faster. We're leaving everything turned on so you get the same experience regardless of what you're doing. We don't want customers having to think about how do I tune my storage. It should just work out of the box. Resiliency and scale, massively highly available. So we always encourage every customer to do a proof of concept, because obviously everything that I've talked about now and everything on these slides sounds fantastic, and I'm sure any other vendor that's kind of worth their salt should also have a good slide deck that says they're fantastic. As a customer, we encourage you to try it. We put our money where our mouth is. We'll put a system on site, and we also encourage you to not just run synthetic benchmarks such as VD Bench or IO meter, you can if you want to, but in the real world, what you should do is take a copy of your production database, put it on Pure, put some copies of your virtual machines on, do your big database test, put some virtual desktops on, and then while you're doing your biggest, most intense, heaviest workload on Pure, while that's happening, pull the power out of a controller, fail 2 drives in each disk shelf, pull out 1 or 2 of the NV RAM drives, pull out InfiniBand cables, pull out SAS cables, pull out fiber channel cables, and see what happens. And you will notice that there is no difference in performance. For some customers, this has absolutely been the key for them, because they can avoid any unexpected downtime or any unexpected performance loss in their environment. So we also have snapshots, we have replication, and we have the what we call RAID 3D. So not only are we protecting against dual drive loss, we're protecting against bit errors, and we're also protecting against variable latency, or what some people would refer to as the noisy neighbor effect. And it's very simple to scale this system up by adding shelves of SSDs. And from a simplicity perspective, if you go onto YouTube and search for Pure Storage, there is a 5-minute demo of our GUI, which, to be honest, is a training course, because there's so little that you need to know about storage in order to manage a Pure Storage array. So there are no decisions around the configuration, around how many drives do I stripe over, what RAID set. We do all of that in the background for you. There's nothing that you need to tune or specify to make it go faster or slower. So we do have a best practices guide for Pure Storage, but all of the best practices have nothing to do with the array itself. All of our best practices are recommendations from an operating system perspective. For example, if you're running VMware, we specify that that you should set round robin as the path management policy, and you should change the round robin algorithm. Instead of doing 1,000 IOs down each path and then swapping, we recommend that you do 1 IO down each path, because we can obviously cope with the IOs much faster. Another example is if you're doing iSCSI multiparting on Windows, we tell you how to create additional iSCSI sessions to get the best performance out of the Intel NICs that we use for iSCSI. So again, similar things for Solaris and Linux. We have recommendations around what you should do at the operating system in order to get the best out of it, because your system is now attached to a very fast, low latency, all-flash storage array. So with that, that's my last slide. If there are any questions, then feel free to ask.
Thanks, Max. So if you do have any questions, if you could just pop them into the questions box, and Max will answer those for you shortly. Sorry, we just had one pop up from John. He says, we use a NetApp storage array already running dedupe. I have 17 TB of storage. Given I already dedupe, how much Pure would I need?
Well, the thing is with NetApp deduplication, or the single instance storage, so that's not an inline process. So the difference between those guys, it's post-process. If you're using your NetApp mainly as a filer, so a couple of things, we don't do NFS or CIFS. We only present our iSCSI or fiber channel block LUNs to the environment. And also, to be honest, if you are using it for file storage, Pure is not really the most cost-effective solution for that. But if you are, if you're doing single instance storage and you're doing VMware, etc., then yeah, we'd have to analyze your environment. Again, the difference would be that if you move to Pure, we get better deduplication than NetApp. So, for example, the NetApp deduplication, it's done on a per LUN or per aggregate basis. So it only dedupes within that. It doesn't dedupe globally. Within Pure Storage, all of the dedupe and the compression is done on a global basis. So everything is compared. So by that standard, we get much better levels of reduction. And it's on permanently. So with NetApp, if you write a terabyte of data in the day, you will need a terabyte of space on disk. And then generally the ASYS single instance storage is generally run as a nighttime process. And depending on what you're doing, some customers can find that the single instance storage can have a huge performance impact. But again, it's kind of horses for courses, depends how high your workload is. But very simply, if you're running something like a server virtualization environment, we get about 6-to-1 data reduction. If you're running virtual desktops, it's between 10 and 15 to 1. And if you're doing high performance databases, it's about 3 or 4 to 1. So it does depend on the data type, but if you want, we can follow up later on with Bytes, and we can go into more detail and look at your environment in more depth.
Okay, thanks, Max. So we have another question. So this is from Steve. He said, in regards to SAN infrastructure, typically have customers upgraded to faster SAN switches or remained on the existing switches when implementing an AFA?
Yeah. So. Well, to be honest, and I think I can speak for most of the all-flash array vendors, is that I don't think any of us support anything less than 8 gig fiber channel or 10 gig iSCSI. So if you already have 8 gig fiber channel or 10 gig iSCSI, then we just plug straight into that existing environment. If you're running 4 gig fiber channel or 1 gig iSCSI, then it's time to upgrade. But having said that, if your environment is running 1 gig iSCSI, unless you've got drastic performance issues, if you're happy running 1 gig iSCSI, then I would suggest that you have a fairly low performance environment, in which case, I'll be honest, Pure Storage could be a little bit overkill for you. But yeah, as long as you've got 8 gig fiber channel or 10 gig iSCSI, that's what we plug into. So there may be instances where, yes, if you're going all flash, you may need to put in some new infrastructure. But as long as you're at 8 gig fiber channel, 10 gig iSCSI, that's what we plug into.
Okay, so thank you, Max. And yep, so that's all the questions we have today. And thank you everyone for joining this webinar.